Okay, so good day to all my followers, if there is. So welcome to the world of computers, World Wide Web. Our lesson for today class is about bootloader, the master boot record, how the internet works, how the computer works. Okay, so when you restart the power button of your computer, it will do the power on self-test. That is the BIOS. This is a small program that runs when a computer starts up and perform a number of tasks. So this BIOS is the one when you saw in the screen when you open your computer. Press F2 for the BIOS, press Escape for the BIOS. So if you enter in the BIOS, you will not enter in the hard disk. This is your BIOS inside your computer. Okay. So when you open your computer, it will run the BIOS first. So what is the BIOS? Okay, so I will demonstrate to you. I have my MS-DOS here, and let's try our chemo. Where's my chemo? Yeah. Okay, I stated here, chemo. Boot in my hard disk. This is the hard disk. Boot on drive C, and the memory is 16. If you want to increase the memory, you can make it 64 MB. This is by MB, megabytes. Enter. Because 12 MB is enough for the DOS. Okay, so this is the BIOS, the one starting. So let's wait for our computer to appear on our screen. Sit down and relax. Relax. Sit down and relax. Okay, so a few moments later, let's wait for the BIOS. Waiting. In 1 hour later. Oh, this is the BIOS. See that this is the one running. This is the BIOS. Okay, then starting and DOS, reading from the hard disk, testing the memory, it's okay or not, blah 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 blah. And after that, if it is successful, then the PC is ready to use. So this is the BIOS. So we're now in DOS. Okay. So now what we're going to do next is this one. Let's try this to clear the screen, and let's try to this one. Our bootloader. Later that one. Okay, so let's put this one as bootloader.bin. Okay, so this is our bootloader.bin later. So I prepare you a small command here. Okay, and as you can see, this is the assembly. This is the bootloader. Okay, bootloader, meaning we will bypass the BIOS. We will speak to the BIOS. Do not show all this set C BIOS version. Do not show that on the screen. Just run my operating system. Okay, remember this class. All the BIOS around the world is starting in 7C00 and the rules cannot be broken due to the compatibility of all the computers. And remember this 7C00 and Aa55. That is the signature. If your computer saw this one, is the magic signature, and start on this one, so meaning your computer is bootable. Okay, so now you can see before we proceed in our lesson, you sip a drink coffee and cry. So before we proceed in our lesson, I want to show you this. You research about BIOS and those interrupts, okay? So this is how they run the interrupts. Okay, this is the courses UMBC undergraduate IT. Just search the Google, okay? Give me BIOS and those interrupt. And as you can see here, there's a lot of interrupts, and let's try to focus on 10. Okay, so they have this interrupt 10. So meaning interrupt 10, if you call that function of the video. Okay, 0, set the cursor line, identify the starting ending line for the cursor. So we will try to scan this, to learn this 10, interrupt 10. As you can see in this fall apart, as you can see in our bootloader here, it is interrupt 10. So meaning they are recalling interrupt 10, and the, like what I told you, AX, BX, C, CX, DX, BP, SP, base pointer, stack pointer, source index, destination index, BP, SP, SIDI. And what happened? That is 16 bits, okay? Now in 32 bit, they put EAX, EBX, ECX, EDX, and ESP, EBP, base pointer. These are the register inside the CPU. And ESP, ESI, EDI. Okay? And this ABCD, there is a high and low. That is AH, BH, CH, DH. That is high. AL, BL, CL, DL. So you can put also that one E here to make it 32 bit. Actually, the computer is only processing 8 bit, and that rules cannot be broken. Okay, that is the cardinal rule of Intel. Okay, so after that, now in 64 bit, they just add here R, RAX, RBX, and so on. Okay, you review, you try to research. Let's continue our lesson. Okay, so move H0. As you can see here, this is 0, function 10, and this is 3, cursor, to get the cursor position, and it says it will clear the screen. Okay, so if this one can clear the screen, why don't we try this one, if it is true or false? Because BIOS are ready-made function, already created by the BIOS interrupts are function already created by the engineers. Okay, so this is our bootloader yellow, and this is our bootloader.asm. Okay, so now what we're going to do is I want to demonstrate to you in debug. It says here that command will clear our screen. Okay, is it true or false? So let's try now. Okay, assemble. Okay, let's go inside, assemble. move A8 00, no need to put X because we are in Intel format. Move AL 03, interrupt 10, enter, and press G as in dog. Press G, go, GO. Press G as in Germany, Gimbo. Enter. See? It's correct. No? Okay. Meaning, it's clear the screen and look for the position of the cursor. Control C. Cannot. Now, now what happened? My DOS is hang. That is the power of chemotherapy. Okay? What you're going to do is to either exit here or Control C in your keyboard. Control C as in C, Columbia. Okay, Control C, and it was closed. Then you restart your computer again. That is the function of chemo. No? You can restart your PC again, and you can shut down your PC and restart again, and let's try another command, something like that. Okay, so as you can see here, I don't know if you still can see, there's what we call BIOS interrupt calls. That's what I'm saying. You see, our computer now is running again, and it's okay. Is it okay to destroy your PC? Is it okay to destroy your chemo? Because that is just a software, that's just a file. Okay, it's not literally your computer. That is a virtual machine emulator. Okay, so I cannot move now. Okay, so I managed to move it now to the left. So what happened here? Okay, let's click this one here. Stated here that the BIOS implementation, basic input and output system implementation, provide interrupts that can invoke by operating system. Okay, so we are in operating system. We're developing our own OS, our OS bootloader, and you create your games and let the BIOS jump to your game, and no need MS-DOS, no need Windows. You can create your own Windows. What I mean, you create your own file, like Linux. They have their own GUI, graphical user interface. It's like Windows also. So as you can see here, there is a function here, function number OE, and put this one to AL, and code of character to display, and call the interrupt 10. So that is the time controlling interrupt 10. That is the function that I'm given here to you, because in calling the mouse interrupt 33. So in video 10 keyboard, there is also keyboard 16/8. You have to call that. Okay, so interrupt 33 mouse. Try to explore this. I'm just giving you an example on how to call an BIOS interrupt. Okay, so from here, let's try this in our DOS computer again, and let's move it here, and let's try. Next time I will not exit, I just show you the exit. I will teach you how to reset your system. Okay, so move A8. Sorry, I need the debug. And let's assemble that BIOS call. move AH 0E, move A, assemble, sorry I forgot to put A, we are trying to assemble now in 100. Okay, so move meaning this is the destination, this is the source, meaning AH is equal to 0E, something like that. It's like AH is equal to 0E. Okay, something like that. Move AH 0E. Okay, in add, let's say the value of AH is 10 and you add 5, so meaning let's say add BX, add AX, comma 10, so meaning the value of let's say AX is 10 already, or 5, let's say AX is equal to 5 already, and you say add AX 10, so the AX is become 15. It's like that because it's holding the previous character, so those are registered in they use on arithmetic manipulation and return value. This A is accumulator, base count data. Okay, so let's try it now and move AL is equal to, actually that is one character, so we can type any character here. You can type Y, and you see my syntax error is I type single and double quote, so it should be both single, both single quote. Okay, sorry, that's not a quote. AL, where is my quote here? In my keyboard. Wrong. So again, assemble to 102. Now we are in 102. Then move AL, comma, where's my single quote here? I think this single quote in my keyboard. Like that. It's not a single quote. Is this the one? Let's try the one in number 1, move AL. It's my single quote on my keyboard. Come on, where is my single quote? For a while, I'll check. Let's hold for a while and let's see. Okay, let's continue. This one is 21 in hex. As you can see here, that is 21 in hex. Okay, then before we continue, I want to teach you some technique in keyboard. Let's say your keyboard, the N is not functioning or the B is not functioning. There is 165 here, you see. There is 165, 164. Okay, so you can see in your keyboard, let's say you want Munoz, you type Alt 165, release the keyboard, and you have Enye. Okay, Alt 164 and release the keyboard, and you have a small n. So this one will become Munoz. Alt 165, then 0 Z. Alt followed by decimal number will give you the keyboard. Okay, let's say your keyboard is, this one is decimal, right? Because decimal hex character. So if letter A of your keyboard is not working, so let's try Alt 65. Alt 65 release. See, become letter A. Okay, so that's it. So you look at the ASCII table and just press Alt 67, Alt 68, Alt 69. Those are the technique. Okay, so now our question mark is, our exclamation point is 21 in hex. Okay, so we're going to change that into 21. Okay, so quit, enter and quit, ls. If you want to, by the way, if you want to edit, let's say you have a command.com or TeachYourSelf. So we have h.com, so you can run debug, enter, then type n for the name, h.com, then load L and go. See, that's how to do it. Last time I tried loading with the file name, so that's not the procedure. Okay, so now let's continue our lesson, and we will do it in 21. So what I want to introduce to you is the BIOS interrupts. These are all where the C programming came from. Okay, so they build a macros of all these interrupts, and they type, def, define, all those things. Okay, so debug, assemble, move AH, let's call the function 0A of the function number of the monitor, 0E, display character. Where's the one we're trying to review here? Where's that? Is this the one? Oh, see, function 0E. Okay, of 10. Function 21 keyboard, function video, 0E. 0E is write a character. Okay, so that's why they are calling 0E. He wants to write the character function of the 10. This is the interrupt 10 for video. So it's calling now the display character, write the character, then it moves to the AL. So you can review that. Try to teach yourself. I'm just giving a sample now of how assembly language is working. Okay, now move AL 21. Okay, then interrupt 21 is the hexadecimal value of the exclamation point. Enter, and let's try to go. That's it, print. So it print this character. Okay, so it's true. So this machine, you press Control Alt 2 in your keyboard. Control Alt 2, Alt 1 to 4. That one is Control Alt 1 to 4. Okay, Alt 1, that is the main screen. Alt 2 is the terminal, second terminal, 3 terminal, 4 terminal. Okay, let's try now to increment. Okay, so let's try now to reset this system without exiting. Okay. Okay, so what is this? Comes what's the process? The application is not responding to program. My PC hang. In the process. Okay, so now like what I said, once you are here, press Control 2 and we go to the second terminal. Let's click here and I think my zoom it is the one. My zoom it is dying. Downloads. Go to my zoom it tutorial. Zoom it download. Where's that? Zoom it tutorial presentation. You watch my zoom it tutorial. This one, so that's the one that's now hang. Okay, now it's okay. We are ready to go. Zoom. Okay. My zoom is not working. Not loaded. What happened? Let's try the other one. Then you type here system reset, enter, and go to Control Alt 1 and rebooting your system. Okay, so sorry for the zoom is out like this and I change okay, so let's continue. Okay, so like what I said, should be like that. So if you want to print here one letter A, you call 41. Okay, something like that. So that's how they do it. Okay, I think enough for the demonstration of how they assemble the program. Let's continue to our lesson. Okay, so our lesson here is I just want to prove you that these are the command. Okay, so where's our bootloader? This is the one. Okay, so we have here our bootloader here. Remember this, 0x 7C00 only. This one is octal. OX or hexadecimal. This one is hexadecimal. Okay. Just put OX and you can type here 1. You can type here 1. But you have to put like this. Okay, those are hex. You can type also FFF. Okay, so what happened here? They clear the screen, then they point SI to message. So this message, this one, this is the variable here. It goes to the source index. Okay. And they call the video page always 0 call, and this 04 attribute red or black. But let's try this one, but this one is black. Then load the bytes. After loading the bytes, this 0. Okay, wait, I will change to red so that you can see. Okay, so this message, this is a variable message, and this is the one. Okay, then they call the function video call function, then load the SB, load bytes into AL. So all the bytes is here. After that, compare AL. Okay, so what is the first byte? Letter H. Is H is great? Is H is equal to 0? Is H equal to 0? No. Jump. If equal, halt, meaning stop the system. So compare the H to O, 0. So it will ignore this. Okay, so it go here. Okay, then it output the function, output the text. Then it go here, increase 1, print the character in AL. Okay, after printing the character in AL here, increase 10, increase the counter into 1, so it goes here already in E. Then this print character will jump here, go back, then load again the SB. It will load the letter E. Is E is equal to 0? No. And they do the looping until it finish this terminator 0. If AL is equal to 0, stop the system. Okay, this is halt. Okay, so that's the thing, that's what happened inside. Remember this is the whole signature, and this one, the 7C00. Okay, remember this 7C00 jump. That is the first time jump the BIOS. Then if you do the programming, it will 7C01. Every text 7C02, and so on. That's why the data is like a snake. It's like a chain, stream of data, until they finish here. Okay, until they finish here. Here, you know what do you mean by this and this? Meaning that is the last character. That's why they put sometime dollar here as a terminator, meaning you consume this length, and minus $2. Okay, so meaning this is the last. Let's say this is 10 minus your dollar, so it's decreasing now. That's what happened. This dollar will maintain the 512 bytes. Okay, anything you type from 0 to 500, still this is the formula. It will maintain 512, the length of the program, because bootloader is 512. Okay, so let's try to assemble this in NASM here. Okay, enter. What you are going to do is to disassemble that, to assemble to NASM. State here NASM minus F format binary, output file name bootloader.bin. What is the program going to compile? bootloader.asm. Enter. Okay, so after compiling, there's no error. We're going to run our chemotherapy. Okay, chemo bootloader.bin. Later I will change the color, that's why I'm preparing this. So say chemo minus drive format raw file. This is how you run a file in chemo. Okay, meaning raw. Format is raw of that drive. So raw is just it's like a garbage. raw materials, it's like something like that. Okay, well, what do you mean? Not a garbage maybe, but you review this in syntax. Okay. Then bootloader.bin. So what we are going to do now, we are going to create our own bootloader or system. Okay, so as you can see from here, when we run the command here, there is this starting MS-DOS. Okay, but in our program it will remove this. All it will be deleted, and you are in control of the BIOS. Okay, okay, let's try our second computer now in chemo. So this is our DOS, and I can exit this, no need. And let's try our chemo and enter. Okay, so let's wait for our computer. And remember the title of my tutorial. I will create my title in black. I will create my title is like this. Remember this. Okay, the title of this is 7C00 and Aa55. Okay, that's the title of this tutorial, and I hope you will understand. Paint. I don't like to go here and click map looking for the paintbrush. That's why. Okay, so this is it. Where's our computer? Still loading. Okay, hold for a while. You see? See? You have now your own operating system. Hello. bootloader. After that, you call the jump and go to your program, and you have your own standalone program. No need Windows, no need Linux. You can develop your own kernel. Try to review the OS dev, and you can create your own. That's why if all the PC in the world have this BC00, it will boot and it will stop running. But they can debug. They can delete it and overwrite again the bootloader. So that's how it works. Okay? So in my second one here, so what we're going to do now is to be happy. Try to continue exploring this in the internet. They're just giving only the signature here. Only this and this one, AA55, but here is 55AA. That's not true. It should be AA55. In Little Indian, I think. Little Indian. The Indianes. Okay. Little Indian. So that's the master boot record now. So you have now your master boot record. Then control this program and jump to your program and do what you want. That's how they develop games. Super Mario is in those, but those Atari that they are selling. I drink first water. Sorry, you drink also. Okay. So now what we are going to do now is to run our yellow here. Where is our yellow color? See, that one is black. Okay, so from here, either you exit here, or you can press Control C, and it will stop your program. See, Control plus C, and your computer is down. Then you can rerun again your computer by just commanding chemo. Okay, but let's try to find out our color version. I want red 04. Okay, so from here you change this to 4. I think here. We can change. It's better we change here. I'll try this one already. I want red 4. Okay, save. Then I name this one bootloader red. Even though bootloader yellow, better that one, because that's the file name already here. As you can see, bootloader yellow. We will run this 3. Okay, just for the sake of demonstration. You have a master boot record now. Okay, then as you can see here, Control C, and your computer stop again. And from here, 04, let's try red first. Is that file save? Then we're going to this one, NASM bin yellow. That's the name, but it will appear red. Okay, so run our computer again. That's the use of chemo. Okay, but you can see 386. You can run also x86 and 64. Okay, then let's wait again. If it's true that our system booting in red, and find a way to jump to your program, link it into your kernel, and do your own operating system. That's the use of that. Okay, that's why try to find a way to jump that one into your code. So that is bootable already. That is a bootable. Okay, and that one is cannot be broken because due to the compatibility of all the version of BIOS. You see, and this one is red. Okay, let's try the green. What's the color? That one is in video function also. Okay, they call the video function 10. Video memory, this is the video memory segment B800. Okay, you try this in the debug and look for the what address is this, and you can do the looping. Okay, so let's try green. Let's change this into 2. Okay, remember this, these are the signature. It should be 512, and the 7C00, that's the where the BIOS jumps. It will jump here, the program, and if they found it Aa55, meaning that is bootable. Any program here, just put only this below and make sure it is 512 KB, and it will run. Okay, you have your own operating system, but you find a way how to jump to your program. There's some LD script I read. We will try soon. Okay, so now 2 green, save, and cancel your computer, shut down. So C, shut down my PC, and it shut down. No more PC again. And okay, then run again your computer, and then that's the function of chemo. No need for you can shut down your system shut down. Okay, and you can review all this you can view all this function. Okay, character generator, right string, this one, read the color. Okay, so I hope you learn something. These are the color in video last time, and there are also resolution. Okay, try to improve yourself now. Okay, so that's what's going on. Okay, it cleared the screen. Functional fills video memory with spaces. This is the area. This is the area of the memory. You can type anything on that area. Okay, let's point to video memory. AX, extra segment. Accumulator, extra segment, destination index. CX is counter. AXB, XCXDX, ALB, LCLDL, that's what I told you. SI, source index, destination index. That's it. There's an explanation here already. On the right, what happened, and how the CPU, and it give you this one. Okay, you can edit this one. TeachYourSelf. You can type a lot. Okay, save that one, and this is our see, it's become green. So you can exit that one, and automatically your chemo will sit here. That's why chemo they are using in developing robots. They're trying to control their bootloader here. Okay, they're practicing the chips to reboot the system, or some cameras. In creating camera, there is a and also washing machine. biometrics program in door access. Those are, there is a Linux kernel. There is a Linux kernel inside. Because Linux kernel is a complete bootable with a small video keyboard, and they can assign that in the system. Okay, you can try your... that's why those devices can communicate to the computer. Especially you have door access, you call your technician and they can remote access that one, and they can reboot the system inside your attendance by that machine. Okay, even the camera. Okay, so your cell phone, there's a bootable system on that. That's why when you open it will reboot. Okay, so NASM bin, and let's see if the TeachYourSelf is there. Kimo, run my PC. You see how many times you off your PC, but no problem because that's only a file. That's just a file. I'll teach you already how to do it. Try to review the syntax, and before I forget, I want to show you the so that is the magic signature Aa55 and 7C00. Once the computer see that in your PC, okay, it will reboot. That's how they do the programming. The BIOS interrupt. It was set up already by the engineers, Intel engineers. You can go to Intel and review their developer manual. Better you do that. So you review the mode RM. In my next lesson, I will try to explain the mode RM. This one. In my next lesson, I will try to explain. But you can research this. Okay. This is how they decode the program. Okay, mode Arman. Okay, RM. And Arman de Castro. Meaning that's only access, data bus, control bus. The other one is access. Access. Never mind. See, there is a TeachYourSelf here. Okay, so that's how they call those functions, and until now they are doing that. Okay, and so data bus, control bus, access bus. I don't know, forget. Okay, so but you review the mode RM. Okay, so remember this class. Remember this. You try to create a small program, but before I forget that one, I want to show you our file here. As you can see, all of them are 512. That's the rules. Okay. Your master boot record should be inside 512. Okay, so see, all binary is 512. 512. Do not exceed on that. Make sure that's the rules. Okay. So how are we going to do that? Let's try this. In the we have here cd dot dot. We have here asterisk point exe, and we have this and this ASM. This is the will display the hex. Okay. let's see, and you find here CD teach yourself. Then from here we're going to end this ASM. I prepared the command already here, and just click for the history if I have. This is it. Okay, in this ASM B, where did you get the B? Again, please review my syntax. Okay, and enter. Once you enter it, it says here, and this ASM B 16. Where's that? No, not that one. This is the one. Okay, and this B16 bootloader.bin. What is my command here? I have here. What happened? The same. Okay, so from here, see, I don't know what the mistake on that. Like what I told you, it will complete, and in the last, meaning it's a bootloader, you see the signature, post base pointer, and put the byte 55AA. So it should be 55AA, but in it's AA55. So that's Indian. But make sure to follow this one. So if you want to review the code, as you can see, they just fill it up all 0, and this is the code. And you can understand this. You can understand this. From mode RM, you will understand this, how they decode this. In the mode RM, there is mode, register, memory, then there is 0 to 7 bytes. I will teach you that on the next video. Please review, research about what are the bash interrupt, how can run, review my DOS, install the DOS, then try it, review all this, what will happen, and apply to 32, because that's what they did. Before is 16, better at least you learn the history, and go to 32-bit, just put all EX, actually they're still using the only the register. But the cardinal rule that never been broken in Intel is we are only processing 8-bit. That's the truth. We're just only processing 8-bit of data. According to my book here, I have a book here with the IBM PS2 from the inside out of Tom Xiangli, and he gave us the cardinal rule of the Intel. And you want to read? Okay, I will read for you. He gave me 3 cardinal rules of Intel, and listen carefully. Where's that now? I close my book. I will pause for a while. By the way, I'll teach you already the redirection symbol here, right? So I'll teach you already this one, and you just put a greater than symbol and bootloader.txt, and better you read this in notepad. Bootloader.txt, and you can read the program here clearly. Okay, and you can save it. At least it was saved. They are the same. Okay, meaning this word is always 0. Okay, push, if you put 55, push BP. You see on the last, that is the signature. If your computer see the 7C00, okay, and the and this no, will reboot any program you try. Okay, so it's like you have your own OS. Okay, listen carefully. It says here the cardinal rules in the Intel world. Cardinal rule number 1. Rule in any system based in 8086, the 86486 microprocessor, every memory and input and output storage location contain exactly 1 byte or 8 bits of information. The temptation is great to say that storage location in a system based on 286, 386, 486 that Intel microprocessor each contain 1 word, 2 bytes of information. Many people think this is the case because the 286 has a 16-bit data bus and can transfer a word at a time. Although its 16-bit data bus allows the 286 to access 2 locations simultaneously. This does not alter the fact that each location contains only 1 byte of information. For some reason, people are tempted to think that storage location in a 386-486 system each contain a double word, 4 bytes of information because the microprocessor has a 32-bit data bus which allows the 386 and 486 to access 4 locations simultaneously. Only they are just processing 8 bits. Cardinal rule number 2. Rule: every memory and input and output address is considered to be either an even address or an odd address. Even and odd. The 286 processor begins a bus cycle when it must read data from or write data to an external device. The address is placed on the address bus signal line. Logic external to the microprocessor looks at the least significant address line A0 to determine if the address is even or odd. Consider the sample address odd and even. Remember this. Number 3. When the 286 processor, 386-486 processor read from or write to an even address, the data, 1 byte, is transferred over the lower data path D0 to D7. When reading from writing to odd address, the data byte is transferred over the upper data path 8 to 15 bit. Okay? Every location contain 1 byte. Summary: every location contain 1 byte of information and is considered to be either an even or an odd location. When communicating with an even location, the 286 processor always use the lower data path. When communication with the odd location, the 286 microprocessor always use the upper data path. These rules are never be broken. The processor must be surrounded by special logic that guarantees constant adherence to the rules. So meaning, it says here, goodbye. Okay, so it says here that you understand that steering like this, they are only processing 8-bit. Okay, and you're thinking those double word, 3 word, it happened that the processor can run this simultaneously, but still they are processing 8-bit. So our 1248 to the left and 1248 to the right is that one. Okay, so in data it's stated that 0 to 8 This is when the even lower. So if the memory is stated here, if when communicating with an even location, the processor always uses the lower data path. Okay, the lower is the data 0 to 7. Okay, D1 to D0 to D7. Okay, that is even. With the even location, always use the lower data path. Even lower, add upper. So if the value is add, it will use the 8 to 15 data path. Okay, so that is a bit from 0 to 15 bit. Then you count 1, 2, 3, 4, 5, 6, 7, half, and 1, 2, 3. That's it. Okay, so thank you for watching. Now you can create a robot. You can create your own operating system, any program. Just install NASM. Okay, easy to install NASM. Just go to nasm.com. Just click NASM in the internet. That is a nationwide assembler actually. Okay, so all of us now, we try to develop our master boot record, MBR, and make sure 7C00, and remember that, and AA55 signature. Okay, and you try at home, and you try to put that one in you use this. Let's say you do the programming already. You use this row push. Okay, and put to your USB. I use row push here because the row push can detect the bootloader. You try that row push, and because it will create an ISO. Row push can detect that is a bootloader, and what you're going to do in row push, like this, go to your click device. What's this? This one. Place this image, select. Okay, so once you select this, click here, and look for the program. We're going to try this many times. You go to our drive PC getting fast now, loaded with the program, loaded with the virus already. F and NASM, and go to TeachYourSelf, and try to click this bin. Okay, bootloader.bin, and select. But I did not put my USB, so you can put your USB first and try this one to save. You watch Rupo. I can teach you this one already, and you try to reboot in